As you can see it on the screen, is object-oriented programming 2. As we all know, OOP is the thing that I feel a little bit hard in AP Java because I'm a competitive programmer. And your next teacher, what ABQ, is fluent in object-oriented programming. But in order to publish my course on the internet, so I will use English to complete this session of AP Computer Science A courses. Well, what will we learn today? Inheritance and polymorphism. First of all, we should learn two terms, superclass and subclass. Have you remembered the term class? A class is an object. A class can contain several objects. An object may be a function, array, reference, and integer, etc. And superclass is an existing class, and subclass is the class created from the superclass. A subclass can be created from an existing class, and the existing class is called superclass, just as I mentioned before. So superclass is greater than subclass. Maybe it's greater or equal, because subclass can just copy all the things in this superclass without modifying it. And the term we'll talk today, inheritance, uses this mechanism to reuse code. Inheritance uses classes to reuse code. Code reusing is very useful, just like we mentioned in teaching the function part. Functions are also a mechanism to reuse code. For example, void sum, int sum, int a, int b, and we return a plus b. And then we can use this function for infinite times when the function is legal in this part of the program. Inheritance hierarchy. there can be a chain or a tree of inheritances. As we learned in the standard classes class, the object class is the superclass for all the classes and other objects. Everything automatically extends object. So object is the global superclass. And from the object class, we can have many subclasses: A, B, etc. So there can be a chain or a tree of inheritances in the inheritance hierarchy. And in AP Java, we will see some figures of the test items to be in the form of inheritance hierarchy. And in order to solve these problems, we should learn inheritance. Implementation, the extends keyword. And this is an example using extends. You can sit it for a while and just guess how it works. Okay, let's continue. You sure guess something about this code, and we will talk about it in later part of the class. Inheriting instance methods and variables. Superclass do not inherit, subclasses do not inherit private methods or variables from superclasses. As we mentioned in classes, class A, a public class A, and we define something private x equals to 0 and public private int x equals 0 and public int y equals to 1. This is a class, and we will define a class named B. Public class B extends A. we implement the B by using A. And then it won't inherit the X instance. So B equals to B object equals to new B, and then we can use B.y, but we can use B.x, not because it is B.x is a private variable. That is because the x does not ever exist. Methods overriding. Any public method in a superclass can be overridden in a subclass by defining a method with the same return type and signature, name, and parameter types. Partial overriding. The code for overriding method includes a call to the superclass method. So this is widely used to reuse the function in the superclass with modifying it by just calling back the original method in the superclass. For example, public class A, and we define a function, public void function, and then we do something, and then we create a class B, extends A. Public void function. We can use super.func, and it will execute all the things in the original func function, and we can add something new here. That's a useful method in methods overriding. Constructors. Constructors are never inherited. A subclass constructor can be implemented with a call to the super method. The second constructor in the undergrad class is called with parameters that match those in the constructor of student superclass. Constructors are never inherited. This sentence is very easy to understand. For example, public class A and public class B extends A. Constructors are never inherited, so we public A and we do something here, and then we end this class, and the constructor can not be inherited, so we should define a public B, and we can call the constructor in the class A by using super. It's also very easy, but please notice, because it can be inherited and something will hurt your AP score. Constructors. Public on the graph. String student name, int student tags, string student grade, and we call super student name, student tests, and student grade. And this is the code from the page before. The second constructor in the undergrad class is called with parameters. Yeah, so we just reuse the student class, the constructor in the student class, in inheriting to the undergrad class. Grad student. Okay, so now for grad student, the constructor is different with the student constructor. He added a line grad ID equals to 0, and this is also something new. Rules for subclasses. A subclass can add new private instance variables. A subclass can add new public, private, or static methods. A subclass can override inherited methods. A subclass may not redefine a public method as private. A subclass should define its own constructors. A subclass cannot directly access the private members of a superclass. It must use accessor or mutation methods. So it's also easy to understand, but you should also pay attention to it. And once you understand it, the relationship with subclasses and superclasses are easy for you in the AP exam. Declaring superclass objects. The green text is the right ones and the red text is the wrong ones. Student S equals to new student. Yeah, because grad student, undergrad are all classes inherited from the original class student. We can draw the hierarchy diagram. Student, and also student have a superclass object. And student have two subclasses: grad student and undergrad. So you can use a smaller one to define the larger one, because student is the smaller one, and grad student have something more than students. So you can define a student by using grad student, which contains more things than student contains. But you cannot define a grad student, which is larger, by the smaller class students. Declaring subclass objects. It's legal to define a smaller superclass by a bigger subclass. It's illegal to define a bigger subclass by a smaller superclass. The type of the first action is the bigger subclass at compile time, or the smaller superclass at runtime. The third sentence is a little bit confusing. The detail of it, we'll talk about it later in dynamic binding. That's also a difficult part in object-oriented programming in Java. Polymorphism, method that has been overridden in at least one subclass, is said to be polymorphic. Polymorphism is the mechanism of selecting the appropriate method for a particular object in a class hierarchy. In Java, the selection of the correct method occurs during the run of the program. And this is dynamic binding, which is a little bit difficult. It selects the appropriate method for a particular object in a class hierarchy. Occurs during the run of the program. So that is in the runtime. And if the runtime can figure it out, you will get a runtime error here. That's also a horrible error. This is the sample code, and you can read it for a while and guess how it works as we did before. and you can just guess what result it will output here as the computer grade. And for this example, when this code fragment is run, the compute grade method used will depend on the type of the actual object as refers to. S is this null, and something will be added into S, and the method we'll use in the compute grade will depend on is an undergraduate student or graduate student. The calculation will be different in different cases. And S is depend on the user input. This is the second example. You can have a look for some time. Okay, here an array of 5 student references is created, as we can see in here, 5 students. It defines 5 student objects. Why we can do this? Because it calls the what can I call it? The constructor of student by default. By default, and because it calls it by default, using this method, in case using this method, you can't just simply transfer the parameters into the brackets, because there's no brackets here. And then all of them initially null. 3 of these references, student 0, student 1, and student 2, are then assigned to actual objects. The compute all grades method steps through the array invoking for each of the objects the appropriate compute grade method using dynamic binding in each case. The null test in compute all grades is necessary because some of the array references could be null. Why they could be null? Because we define 5 objects. And we just assign 3 values in first 3 objects. And for stu 3 and stu 4, they are null. And if you try to access something in a null object, you will also get a runtime error because there's no appropriate mechanism the runtime can be used in this case. Using super in a subclass. We have mentioned it before, and we use code to describe it in detail. Type capability, downcasting. That's also what we mentioned before, and we just use code here. Like Z. Z is the A converted to B. So B A equals to new B. And then A will have everything in B. But you can't directly access the value extension in class B because the type of it is A. But you can downcast it to B and then access the value extension in the class B. But you can use B once you quit this case, what will happen here? You can think it at home and tell me after the class. And why we should use 2 brackets here? Because the priority of dot is higher than brackets. So we got a compile time error here because we add the brackets here. Might use another color. So obviously it's illegal. Hey, sorry. Abstract class is also a special type of classes. It's in many aspects, abstract classes are just the same as the normal classes, but abstract classes can be directly initialized. As we can see, A equals to new A, this wrong, and AC equals to new C, this also wrong, and although because C is also an abstract class. And we can also get that information here, is that an abstract class can also extend other classes. Whatever it is, it can be the superclass, can be normal class, can be abstract classes, and normal classes can also extend the abstract classes, but the abstract classes cannot be used regularly. We should extend it to another classes, and then we can initialize the extended classes, the subclasses. Interfaces. An interface is a collection of related methods. A class that implements an interface can define any number of methods. You should provide implementations for all the non-default abstract methods declared in the interface. If it fails to implement any of the methods, the class must declare abstract. So an abstract class can implement part of the interface, but a normal class must implement all the methods in an interface. So this is the usage code sample for interfaces. Abstract class versus interface. Use an abstract class for an object that is application specific but incomplete without its subclasses. Consider using an interface when its methods are suitable for your program but could be equally applicable in a variety of programs. An interface typically doesn't provide implementations for any of the methods, whereas an abstract class does. In Java 8, implementation of default methods is allowed in interfaces. But although Java 8 is the most popular Java version this time in modern time, the AP Computer Science exam don't contain anything in Java 8. an interface cannot contain instance variables, whereas an abstract class can. It's not possible to create an instance of an interface object or an abstract class object. So you can directly use interface object also. That's all for object-oriented programming 2. And that's all for all of the object-oriented programming contents and AP Java subset. Congratulations, you have just completed a very difficult part in AP Computer Science exam.